So today we're going to do the derivative of x power x. So we're going to solve the derivative of x power x. So we need to find d by dx of x power x. So let's get started. So we have the function, let's say y equals x power x, so we need to find dy by dx here. So if I apply logarithm on both sides, this becomes applying logarithm on both sides, I get log y equals x log x, because the property of logarithm is that if you have log m power n, you can write that as n log m. So using this, you can write this like that. Now I'm going to apply the d by dx on both sides, like derivating on both sides. I get derivative of log y is 1 by y, but I'm doing implicit differentiation, so you need to multiply by dy by dx. And on the right side you have a product of 2. So when you have 2, d by dx of uv, like the product of two functions, is v multiplied by derivative of u, I denote that by complement, plus u multiplied by v complement. So we will use this here. So this becomes, this log x stays here, derivative of x is 1, multiply that by 1, plus you have x here, and derivative of log x is 1 by x. You can cancel an x here. This becomes 1 by y multiplied by dy by dx equals log x plus 1. So here I assumed that y equals x power x, right? So I'll bring the y here. So I write dy by dx equals y times, I put the parentheses here, log x plus 1. So if I replace y by x power x, I get x power x 1 plus log x. So this would be the answer for d by dx of x power x.